Hello everyone. This presentation is about the golden ratio. My name is Alberto Vazquez. Let's begin. A little disclaimer from people from YouTube. I am not an expert on the golden ratio. This is my best attempt at explaining the golden ratio. I am no expert. I'm sorry if I get anything wrong. This presentation is meant for the Math Study Skill class. What is the golden ratio? In simple terms, the golden ratio is a phenomenon mostly found in nature. This is when one finds a spiral in nature or horticulture. The golden ratio is associated with the Greek symbol phi, that being this symbol right here. The golden ratio is roughly equals to 1.618. So next time when you go outside, look at a flower, preferably a sunflower, look at its petals or seeds. Let's take a break from the golden ratio in nature and look at the golden ratio in math. The golden ratio is an irrational number that roughly equals to 1.618. There's only one true golden ratio, phi, in every piece of nature, architecture, and rectangles. They have their own ratio, but it isn't a golden ratio. This is because the golden ratio is a specific number. They may come close to the golden ratio, but isn't considered a true golden ratio. Let's do a little exercise on the next slide. Choose the most appealing rectangle. I'll give you guys some time to choose. Lock in your answers. Alright. If you chose the last one, congratulations. This is the most appealing rectangle. This rectangle is the closest to the dimensions for the golden ratio. This is the main reason why people will choose this rectangle over the rest. However, it shows these three. I don't know what to tell you. These are the least appealing rectangles I made. And isn't the rectangle that has a golden ratio. But it was a good choice if you did pick the other three. So, if the golden ratio appears everywhere in nature, or in architecture, does that mean everything have a golden spiral? For example, this vine, sunflower, galaxy, shell, this plant, and this hurricane, and this Roman building. Short answer, not exactly. Here's the explanation. While we can't see the golden ratio in everyday life, it isn't exactly the golden spiral. Since the golden ratio roughly equals to 1.6180339,887. If the ratio isn't phi, then it doesn't have the golden ratio. For example, this picture, the golden rectangle. It is 1.618 by 1. This is considered the perfect since it has the golden ratio, as we can see here. Explanation part 2. While in nature, the golden ratio comes close to phi. The sequence that comes the most closest to pi is the Fibonacci sequence. As the Fibonacci sequence increases, the ratio of consecutive terms converges to the golden ratio. As you can see here, in the picture here, 0 plus 1 equals 1. And we add that to number precedes that 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 equals 8, and so on. This sequence allows us to get a closer understanding to the golden ratio. Why the Fibonacci sequence? The Fibonacci sequence is a set of numbers that get closer and closer to the golden ratio as it grows. For example, if a rectangle is 5 by 3, the ratio of that rectangle is 1.666 repeating. Pretty good, right? If the rectangle is 55 by 34, then the ratio is 1.6176. This is far closer to the golden ratio. However, it doesn't mean it will reach the golden ratio. In this image right here, we have the Fibonacci sequence. We're expanded. It gives us a better understanding of the Fibonacci sequence. The golden ratio equations. These are the equations of the golden ratio. Each of them are different, but all correct. As for this rectangle, it must be phi by 1. If the rectangle were to grow by 10, each side must be multiplied by 10. For example, phi times 10 by 10. This is a golden rectangle. As each grows, for example, 100, it must be phi times 100 by 100. This is the most famous equation and the most basic. A, the long side, plus B, the short side, over A. This will equals A over B. The algebraic equation of x equals A over B is x squared minus x minus 1 equals 0. The exact solution, or the quadratic formula, is phi 1 plus or minus the square root of 5 over 2. And phi is always the positive and not the negative. This is the number value and the most I am willing to put down is 1.6, 18, 03, 39, 88, 74, 98, 94. This is the rough estimation of pi. Now you try. On the next line, I'll be giving you a rectangle, and you have to solve the approximate golden ratio. Alright, find the golden ratio of this rectangle. 89 over 55. Make sure to get out a piece of paper, a calculator, or anything you need, and use the equations from the previous slides and solve the golden ratio of this rectangle. I'll give you half a minute or a minute to solve it. Ready? Go. Mm. 20 seconds left. Alright, sit down your pencils. I'll relieve the solution. A very easy way is putting it like this. 89 over 55. This roughly equals to 1.6, 18, 18 repeating. It's pretty close to phi and its whole number. So good job if you got something close to that. Congratulations on everyone who made it this far to this video. To summarize, so while we see the golden ratio in everyday objects like flowers, buildings, weather, and other natural phenomena, it is not the golden ratio, but more like their own version of the golden ratio. As we already know, the golden ratio, phi, is 1.618, and so on. It's an irrational number. So something is either is or isn't the golden ratio. There is no in between, no matter how close they are. As you can see here, the seashell cut in half. We can see the spiral as it goes trickle down to the end. While it might look perfect, it isn't fully the golden ratio. It might be off by a couple decimeters above or below. Alright, these are my sources. So golden spiral, Wikipedia, golden ratio, Wikipedia. I don't know why these two are different. They should be the same. I don't make the rules. The Fibonacci sequence, Wikipedia. Thank you all who lasted this long. It's been a pleasure, and until next time. See ya.